Okay, hello software architecture lovers. This year we were delighted to host Niklas, Chief Architect at Spotify, at the Global Software Architecture Summit, where he presented a data-driven study of a large-scale microcomponent architecture, and the Q&A session that followed generated an abundance of questions, prompting us to arrange an extra online Q&A session to address as many as possible. So this presents a unique chance for you to pose any queries pertaining to software architecture. You can post your questions on the chat that you see on YouTube, and Niklas will read them and answer them right away. So don't miss this opportunity, and you can actually start posting your questions right now. We hope you enjoyed this session. And Niklas, thank you very much for finding time in your agenda for this session. It is always an honor to have you with us.
Thank you very much, and I'm happy to be here again. It was a really fun session in Barcelona a few weeks ago, and tons of good questions from the audience. So I hope we'll be able to cover some of the ones that I didn't have time for at that point. And if anyone has additional questions, I'm happy to try to get to those as well as I can. And I see we have a first question, which I think came from the remaining questions from the live session. So I'll start with that, but as mentioned, please put in any other questions that you have. So the first one, so quick context setting from that session. Spotify runs what you could call a microservice architecture, but it applies across all types of components. So not just backend services, but we design our data pipelines or mobile views and so on in a similar way, having them being fairly small, reasonably isolated components with clear ownership, and they can be deployed independent and things like that. There are some constraints, of course. So with that in mind, I think some of the questions that at least came from the session was around like how to deal with that at large scale and so on. And we have a few thousand of these components, so we have at least some learnings. And I'm going to be pretty honest about where we have both good stuff, but also our weaknesses. So the first question is, does each component possess its own CI/CD pipeline? So the basic answer is yes, with the exception of our mobile apps. So I mentioned that also on mobile, we view our architecture in a way where we have these like small components. They all live in one large repository, and they all in the end get compiled into this one binary that we ship to our users. So for mobile components, we build those as with a shared pipeline that is for all our mobile components on its own, and that's thousands of components. For anything else, backend data pipelines, websites, things like that, they run with their own pipeline. As you can imagine, we have try to make an effort to make sure that those pipelines look as similar as possible. So we have a set of templates that we hope can apply to most components. So there's like a template pipeline for a backend service, a template pipeline for a data pipeline and whatnot. And most components can use those templates, which means that it's not that we have thousands of different pipelines. You can customize those pipelines if you need to. So you might need add some specific step to your pipeline, or you might have a sort of outlier of a component and define your own pipeline. All of those things are possible. We have our own custom CI system, which is currently built on top of Jenkins, although we are replacing Jenkins at the moment. And that's what resolves these pipelines and runs them. And in the end, they end up being a bunch of Docker containers that gets applied to the component, and in the end, it gets deployed. Next question. If you were to initiate Spotify now, would you contemplate substituting Kubernetes components with cloud-based microservices, lambda, ECS, step functions, and so on? So there's a bunch of different technologies in here. So let me try to break it down. So first of all, Spotify do deploy our backend and the data processing on Kubernetes and websites on Kubernetes today. There's a fun backstory here in that we built our own container orchestration system. It's called Helios. We proudly announced that at, I think it was DockerCon, or I don't know if it was actually called something else back then. It was many years ago. We proudly announced that and open sourced it and all of that, and we were super happy about that system. And then literally at the same event, the day after, Kubernetes was announced. And we pretty immediately understood that Kubernetes has a lot of benefits over the thing that we had built. But we had already rolled that out. It was used all over the place. So we have since then moved on to Kubernetes and moved off our own orchestration system. We still have that in a few places, but by far the most services runs on Kubernetes today. So then the question, and we use managed Kubernetes. So we use GKE on Google Cloud, where we have by far most of our capacity today. So if I break down the answer, there's a part of it where an example would be ECS. I don't think we would use a service like ECS. There are those options available, but I think if you want something that runs containers and does that at the scale that we are at, Kubernetes is probably the best option out there today. We use many servers to power our very large Kubernetes clusters. So I think it would be challenging to do that with the same level of scale and functionality on other container orchestrators. And then there's another maybe more interesting question of like, should we rather go with more of a functions-based approach like a Lambda, or Google have cloud functions, like there's a ton of these available. I think that's a more challenging question. I don't have a very good answer. There are trade-offs. I don't think any of the available high-level products that are out there today would be fully ready to run our scale and sort of depth of functionality. But you could imagine we could build that abstraction for our developers, which is not something we've done today. So that is something we're from time to time are discussing and might do, but we haven't decided to do today. So today, the abstraction that engineers use is the container, and that's what runs in our production environment. Next question. How do you handle architectural decisions made by teams that could introduce technical debt? What safeguards do you have in place? So this is maybe the most fundamental question of my existence in a way. So we have hundreds of teams. They make thousands of decisions every day. And not all of those decisions are, in hindsight, great. That's always going to be the case. Many decisions that I've made have turned out not to be great in hindsight. So there's always a risk of introducing technical debt. And in some cases, you intentionally introduce technical debt because some other aspect like shipping quickly or whatever is more important at the moment. And then you have to go back. So I think what's important to us is to have the right balance between being able to spend time on technical debt versus, let's call it product work. And maybe versus is the wrong word there, but because of course, like technical debt, fixing technical debt only serves to make us faster on the stuff that we actually want to do. We don't want to work on technical debt if we could avoid it. So we have put a bunch of mechanisms in place to be able to deal with that, both locally, where we encourage teams to dedicate a certain amount of their bandwidth towards technical debt work. We have prioritization mechanisms at the company level to make sure that we can prioritize high impact technical debt work. And we have, in the presentation, I talked a lot about the different metrics that we use, and we also measure this. So we both try to measure this at the quantitative level, like there's a bunch of measurements that we do that are trying to assess different aspects of technical debt. And we also measure engineers self-assessment around how their teams are doing in terms of technical debt. Are they investing enough time into it and so on? And these are high-level metrics that we review on a quarterly basis as part of the technical leadership at the company. Next question. Could you share, so I don't know who asked these questions, otherwise I would have sort of called you out and thanked you, but they are anonymous to me. Could you share an instance where a metric, fitness function, triggered a change and how the organization addressed it at a broader level? Yeah, absolutely. So let me take a particularly impactful decision and strategy we put in place. This is now a few years back, and we had at the time in our mobile apps, I mentioned that they are like, we think about them as sort of microservices, but they live in this one big repository, or one repository per platform. And we had not done a great job at ensuring that the architecture for those apps could keep up with the scale that we had and the number of developers we had working on it. So they had turned into, and we had gone from like having one developer per platform. When I started Spotify, we had one iOS developer and one Android developer. And at this point in time, a few years ago, we had hundreds of developers per platform. So, and our architecture had not kept up with that. So we had ended up in a situation where our apps were in practice highly monolithic. And if you made a change to them, it would either break something unexpected because there were unintentional dependencies between different parts of the app, and or it would be very slow to work with because any change you made would require rebuilding a big part of the app. And much of these insights came out of metrics that we had for these apps and how we were doing, both developer experience metrics of like what's the cycle time to work in the apps, what's the CI times, those types of things, but also a bunch of architectural metrics on what level of modularity do we have, those types of things. And this led to us, combined with being inspired by a few other companies that had ended up in a similar situation and learning from them, we put in place a strategy a few years ago on re-architecting our apps and getting them into a much more modular state where we can actually work and scale with them much more independently than we could prior to this. Most of that work has now been completed, and if we look at the metrics, we keep measuring the same things. We can see that all of the metrics that we are tracking have improved, and so has developer happiness around working in those apps. Next question, and there are lots of these examples. I think this is maybe the most sort of large scale and impactful decision that I can come to think of, but we make these decisions continuously based on these types of metrics. Next up, how do you ensure compatibility across dependent components? Is it through contract testing or versioning? I think I got a question at the talk on this topic, but I'll answer it again and maybe provide a little bit more context. So if we talk, as I'm assuming this is primarily around like service-to-service compatibility or maybe data set compatibility where you have some sort of API contract, but you don't necessarily have a tightly coupled API dependency. Like in our mobile apps, since we compile all that code together and those are like Kotlin dependencies, we will catch if we have, we will typically catch if we have compatibility issues. But with a backend service where you have some sort of API schema and you change that, you might break other services, of course. And I think what I said at the event is that we actually don't do much to protect against this today. And we, in terms of enforcing that, and we at the same time also have fairly few examples of where this break. And I don't have a good answer to why that is. We do have a pretty strong versioning convention. So we make heavy use of protobuf and gRPC, which comes with pretty good conventions for how to do versioning in terms of fields always being optional and things like that. But you can still, of course, break APIs. But it's relatively rare, and but still, we could probably do more. So We do have some spots where we do consumer-driven contract testing, but it's pretty rare and not something that we have in place in a structural way. This is arguably an area in which we should improve, but again, we haven't had that much problems. It hasn't been high priority for us. Next question. With a substantial code base, are you using a super repo or are component code bases segregated in some manner? If so, how? Yep, so we use a mix. So I already mentioned that our mobile apps live in large repositories. They are currently one per platform. So we have one Android repository, one iOS repository, one desktop, and one, we call it the desktop and web, like our web player and desktop lives in the same repository. We are currently working on merging those into a shared client repository, which is ongoing, and I think we're planning to finish up sometime next year. The rest lives in many small repositories where most of them is one component per repository. So we have tens of thousands of repositories. And I think I mentioned at the talk that we have something we call fleet management. There's a bunch of blog posts that we published on this if you want to read in more depth. But that's the infrastructure that we use to be able to make changes across thousands of repositories. So using that tooling, you can author a change and that will get applied across those thousands of repositories in a way that allows us to fairly quickly iterate on our fleet of components. That being said, this is of course a trade-off. You could imagine doing this in a monorepo instead. Monorepos has other challenges around scalability and so on. So this is a question that we're always considering, like is now the right time for us to move to a monorepo, or should we stay in this polyrepo strategy that we're currently in? And currently we've been pretty happy with the polyrepo, but again, we might reassess that in the future. Next question. What tools do you use to build diagrams? So I suspect this refers to the dependency diagrams that I showed in the talk, which is these like network diagrams that shows like a node for each component, and then there's a dependency in between them if they are somehow dependent on each other, like a backend service calling another backend service, or a data set depending on another data set. So there are two parts to this. One is to collect all that data, to know which dependencies we have. And that is very custom to our infrastructure. We have instrumentation built into our service frameworks, into our monitoring, into our scheduling, into our actually extracting from our runtime environment. And we collect all of that up and we store it in BigQuery, so we can use that to query what dependencies we have in our software. And there are, I don't actually know exactly what the number is, but like tens of thousands of those dependencies. Then to actually generate those diagrams, I use that data from BigQuery, and from there on, it's pretty standard software. It's just like GraphWiz to do the layout of that diagram, and it's just visualized in a Python notebook like everyone else uses these days. So nothing magic in terms of that, and the hard part is the instrumentation. Next question, how often do you need to version API? So I suspect this might refer to like how often we would break API compatibility in a way that forces sort of the next major version. This happens, so again, most changes to APIs we are able to do in a backwards compatible way, so we don't have to go around and change every client to that API. But there are, of course, cases where we need to bump versions for some reason. That is a very hard and a fairly costly thing to do. So it's something that we try to do rarely, in particular if you have something that uses that have lots and lots of clients using it. And even worse if it's an end user client. So lots of our API calls to our backend comes directly from our end user clients. And if anyone is out there and are experienced with shipping mobile apps and desktop apps to lots of users, you will know that many users are quick to upgrade, but there are always some share of users that will remain for years on some old version because they might be on an old operating system and not able to upgrade, or they don't have automated updates or whatever it might be. And we usually try to support our apps for at least a few years. So that means that even if we bump the major version of an API, we still have to support the old version. So then going back to the actual question. So we do this fairly rarely. It does happen for various reasons, like some legal reason or some service that is in really bad shape in terms of technical health, and we need to replace it or whatever it might be, and in a way that we can't do with API compatibility. And it's hard to do, and it takes a lot of time and a lot of effort. So it does happen, but it's rare. Okay, let me actually talk through an example, maybe one of the more advanced examples we've done. So this was around the time when I started Spotify, maybe 11 years ago or something like that. We had our playlist system at the time, which, as you can imagine, for a service like Spotify is a pretty central system and a central API. And it was called Playlist 3. It was the third generation of our playlist system, or actually the second, because I think we skipped the version somewhere. But and the API was very wonky and weird. It was roughly based on a streaming XML protocol similar to XMPP, for those familiar, for weird reasons. And we wanted to replace that. And that meant, but of course, we had tons of clients out there, end user clients out there, still using that API. So for many, many years, we would actually run the new service with the new API and then a separate translation service that would still expose the v3 API and be able to translate that, keeping some state to be able to translate it to the v4 API. So those changes are very painful, and we have actually not since then changed our playlist API in a way that breaks version compatibility. Sorry, long answer to a short question. Next, when detecting dependencies for coupling, what mechanisms do you employ? Is it restricted to static code API calls or perhaps even dependency injection? Trying to interpret the question. So maybe this refers, so I talked a little bit about some of the work we've done in our mobile clients to decouple them further. This refers back to what I mentioned earlier. And there's actually a great talk out there that you can Google that two of our engineers gave at BasilCon, I want to say last year, and you can find it out. It's great, and they talk in much more detail than I did. So you'll probably find the answer in there. Yeah, so I don't know exactly how to answer the question, but as part of that effort, a big part we did was to employ dependency injection across our mobile code base, where we had dependencies that otherwise led to where we made a change. We had to rebuild a very large part of our code base, which meant that our cycle times, our CI times exploded. So again, go watch that BasilCon talk, and I think you'll get more than enough answers from that. And they also talk about how they did a similar dependency analysis to prioritize, like sequence how that work was done. It's pretty cool. All right, from Javi, how do you handle authentication and authorization in a Kubernetes microservice environment? Do you use any special tool? Yeah, so since this goes into security, I won't be able to talk very detailed around the implementation, but we do use our own custom service-to-service authentication. It's built on top of just normal JVT type of tickets, but the way we actually build it is custom to our service infrastructure. Next question, how do you manage pull request reviews to handle the significant number of dependencies between squad and components? Not sure I understand the connection here exactly, but maybe one way to answer this question is that yes, so we use GitHubs, we use pull requests for everything we do, and lots of those pull requests are between teams. So all the source code for Spotify is available to our engineers. So if you need a change in a component that your team doesn't own, you can decide yourself if you want to go ask the other team to make that change, or if you want to make it and send them a pull request. And if you do the latter, they then can review that and decide if that's a change that they can support and merge into the code base. So we have a lot of our peers. I think off the top of my head, I think it's like 40% or something like that of our PRs are in between teams. So for some teams, they get lots of these because they might own very central components and they get more pull requests. And for some teams, this has actually caused congestion where those teams can't really have a hard time managing the load of PRs they are getting. And in those cases, typically what we do is that we try to solve that by redesigning that component in a way where, rather than having everyone having to send pull requests to that central component, perhaps we can introduce some extension points where people can extend the functionality of that on their own in components that they can own themselves. So a good example of this would be within Spotify app. For those familiar with the app, we have a view. This is in the mobile apps. It also exists in the desktop app, but this problem specifically was in our mobile apps, both on Android and iOS. We have what we call the now playing view. So this is where you can see what's currently playing. There's maybe some album art or artist art, and you can see the progression of your playback. Nowadays, there's a lot of additional information in that on the artist and whatnot. And this turns out to be one of the most central mobile components we have, and lots of teams needed to make changes in this component. And the team that owned it basically was only reviewing PRs and like working with teams to support other teams, and they couldn't make progress on their own development of the now playing view or managing their tech debt and so on. So they redesigned that view in order to be more extensible, where teams can actually make extensions to that and own those extensions on their own, and that central team do not have to review all of those changes. There's still some changes they need to review and some stuff that we haven't built extension points for, but generally that's the approach we try to take. It's not super hard. It's not super easy at scale to identify where we have those congestion points, but that's something we're trying to improve through more instrumentation and metrics. I don't know if I actually answered your question, but if the person who asked that question is here, you can repost it if I answered it in the wrong way. Next question. When you update a contract, what approach do you adopt? Does a new version imply new components? So I think I partially already answered this before on the versioning stuff. A new version does not imply a new component necessarily. That's up to the team that designs those components. We have many components, in particular backend services, which supports multiple versions of their APIs and manages the translation between them. And then, of course, we try to go back and be able to clean up those old APIs after a while, but like I talked through before, that can take some time in some cases. Next question. Have you encountered any metrics or approaches that proved unhelpful? Any lessons learned? Yes, all the time. I'm someone who specifically works on trying and exploring new metrics all the time. And I'm going to say that most of those cases turn out not to be useful. And for many different reasons, they might just be poor ways of measuring something. They might not be sufficiently precise for the types of decisions we want to use them for. Or I would say perhaps most commonly, they're too complicated for people to understand. At least that's what I'm finding. I'm finding that a pretty common challenge, where someone like myself or some of our insights folks who are like very deep into our metrics might understand them, but in the end, we have to be able to explain this to a bunch of different stakeholders who in the end make the decisions around them. And if the metrics aren't easy to explain, they're not going to be very helpful. So yeah, there's a challenging trade-off between these different dimensions of like precision and ease of understanding and whatnot. So it's always a challenge, and we continuously try to iterate on these metrics. An example that I actually use is that dependency diagram that I showed at the talk. I actually don't find that diagram all that useful. Like, it doesn't actually show very useful metrics. Like, yeah, it looks crazy and whatnot, but it's not a very useful thing to use as a metric. But it turns out to be very effective in telling a story around like how complicated is our architecture. So even though, again, I didn't initially think it was a very useful graph or a very useful type of visualization, it has turned out to be very useful in like telling a story around how our architecture works. And that's also the value of these types of visualizations. Approximately how many services are owned by a squad? So maybe I should talk about this from the component point of view rather than services specifically. So the backend service is a type of component, and not all squads owns backend services. Some squads only own, let's say, data pipelines, and most squads owns a combination of components. So they might own a few services, a few pipelines, maybe a mobile component, maybe a website, depending on what their mission is. I'm going to take this off the top of my head, so I might get it wrong, but I'm not going to get it very wrong. The median number of components that a squad owns is roughly somewhere between like 5 and 10. I don't remember the exact number. And there's a lot of outliers in that. The distribution is heavily skewed. So there are a few squads which owns hundreds of components, in which case they are typically components that are automatically generated in some way. So we have some cases where we might generate new components based on some type of automation. So there are some teams that ends up owning hundreds of components, but they're usually very lightweight from a maintenance point of view, and are a bit of special cases. Again, most teams own a handful of components. Next question. From an architectural point of view, what's your biggest pain point currently at Spotify? It's a good question and a hard one. It's hard to call out any single one. There are many challenges at any point of view. I would maybe group them together and say, if I would actually try to answer the question. So I mentioned before that we have this work around fleet management and maintaining our software. I would say like that larger problem is probably the biggest challenge we have at the moment, with software ecosystem that grows much faster than the number of developers we have. How do we ensure that our developers are not getting swamped by maintaining all of that software, and how can we make it cheaper to maintain our software and automate more of that maintenance? That sort of problem space, and there's lots of things in there. There's the fleet management type of work that we've done, which is all about automation. It goes back to the polyrepo versus monorepo question we had before. It goes back to the lambda versus containers question we had before on how can we make our frameworks in a way where it minimizes the amount of maintenance that engineers need to do. So it's a very like multidimensional and complicated question, but I would say like that's most top of mind for me. And then there's lots and lots of smaller parts to that. Next question. How do you automatically generate a whole component? Could you describe the process in detail? Yes, and you can actually try this out yourself. So the way we do this is so we have Backstage, which is our developer portal, and is the main tool that developers at Spotify use every day. I use it many times every day. And we have open source Backstage. So in Backstage, there's essentially like a wizard-like API that you can walk through, and you can pick from a number of types of components. So like, I want to create a Java backend service, I want to create a Python data pipeline or whatever, and walk through a few steps where the UI asks you a bunch of questions around your component. And then once you've given that input, it will it's pretty easy to imagine what happens next. Like it uses a cookie cutter template for what a typical component looks like. We have many different types of components, but it creates a Git repository for that. It registers the component in Backstage. It registers the component in our CI and actually does the first CI build and the first deployment of that. So after you click create on that component, it maybe takes 30 seconds to a minute, and then you have that component running in production. And that's how we create all our components. And this was something that going back to questions around metrics, this was something that we very intentionally wanted to shorten this time. Like, how many can we reduce the amount of steps that developers need to do to create a new component? Because all of these things used to be manual. Like, you used to have to do this, setting up your thing in the CI. You had to figure out how to deploy it. And at some point, I'm not going to remember the exact number now, but we did like a run through of this. What does it take to create a new backend service? And there was like 51 steps or something like that. It was something insane. So then we thought like, yeah, we're going to have to fix this and automate this. So that was how we started building this. And over a number of years, we have like automated more and more and more. And today it's very easy to create a new component. That being said, that's just like day zero of that component. And the more challenging questions comes later of like, how do you then make changes now that you have thousands of components? And that's, again, brings us into the fleet management stuff that we talked about. And this is available in our open source Backstage. So this component creation part is in there as well. Of course, you won't get our templates because they build on our internal infrastructure and our internal frameworks, but you can get a sense of what that experience looks like in open source Backstage if you want to try it. Next question. How do you coordinate releases of different components? Do you employ GitOps methodology? So let me start with the last question first. So we do use GitOps in terms of that we try to keep as much data around our software as possible in Git. So I mentioned Backstage before. You could imagine that in Backstage you have more of a UI-based interaction, but in the end, most of those changes actually ends up making changes in Git, because that's where we want to keep the source of all metadata and configuration for our software. So yeah, pretty much everything we have is in Git. There are a few other parts to it, but we are actually gradually moving that into Git as well. So then the other question is, how do you coordinate releases of different components? And the answer is, we try not to have to coordinate. That's the point of having a micro component architecture, is that we don't need to do coordination, because whenever we need to coordinate, that means that our teams slows down because they're going to be waiting on some other team, and the coordination becomes very expensive. So for wherever we can, we make sure that we don't need to coordinate, and teams can deploy whenever they want. And we have, I think I shared the number at the talk, but we have thousands of deployments every day into our production environment. One big exception from this is, again, our mobile apps, because they get compiled into one big binary and we release them through the app stores, which requires us to release them in a more coordinated way. So for our mobile apps, we have a weekly release train for them. So every week we will create a new release branch and the teams will go through and make sure that we can release that app, and then we ship it to our users on a weekly basis and make sure that our teams can continue working in the meantime and like merge changing into it while we're stabilizing that release branch. Next question. Considering the number of components connected during your request, how do you maintain high performance rates for synchronous communication? Yeah, so this is a great question. And this, I think, is a challenge in all large-scale microservice architectures. I assume this is primarily relevant for backend services. So what might seem like a single request from our clients to our backend might have a very large fan out in our backend. It might end up hitting a single request might end up causing or like have a fan out of hundreds of requests in our backend in the end. And it is challenging to make sure that you have sufficiently good performance for that. So this is something that our teams work pretty consistently on to make sure that from their point of view, they have a good, they have a sufficiently good latency in particular. We do have some infrastructure for this. So we have like load testing infrastructure. We do have some amount of distributed tracing, although we're not as good at distributed tracing as many of our peers. We do have pretty good monitoring infrastructure, so we can measure what our performance are. But yeah, this is a hard problem, and a lot of work goes into optimizing this. And then there's a question on synchronous communication. The part of the question was on synchronous communication. So that is true that if you sort of zoom out, most of our service traffic is request response, and it's synchronous in the way that a client or a service being a client will call another service and wait for the response to come back. That being said, the underlying protocol that we use is highly asynchronous. So the way our backend services are built is very asynchronous. So they will use make heavy use of queuing, and the code is asynchronous in order to be able to scale to the number of requests we handle and the scale we handle. So this makes it a little bit more complicated to write and implement the service, because you have to work in this async way, and our services are mostly in Java, which up until the very latest release have not have great APIs for async APIs, but now with more lightweight threads, we hope that's going to change so we can simplify our frameworks a bit. Next question. What's your perspective on monorepos, particularly concerning atomic commits and ensuring all dependencies work together? Yeah, it's a good question. And I mentioned before that we're continuously assessing, like, should we be in a monorepo versus being in this polyrepo world that we are in today? And we do have some fairly large monorepos in our client apps. So we do have a reasonably good experience of what it means to work in a monorepo, although not at the scale of like the Googles and the Metas. So I'm not going to be able to speak to their learnings. What we do see is that atomic commits, since the question were, well, actually, let me start with the dependency part. So for dependencies, we actually solve this also in our polyrepos. So the way that we approach dependency management and ensuring that we are up to date and that we have a compatible set of dependencies is that we have centralized that. So for example, for our backend services, which are, I just mentioned, are in Java, so we build them with Maven. Maven has a mechanism called a BOM, a bill of material, where you can centralize dependency versions. So we do that. So we have a central BOM for all of Spotify that almost all of our services use. And in that BOM, we actually guarantee that all the dependencies and versions in that are compatible with each other. And the BOM maintains more than 1,000 different dependencies at this point. And we use similar mechanisms across our other package managers. So we have a similar thing for SBT that we use for our pipelines, and for Yarn that we use for our websites and so on. So we have found that this works well, and we bump the version of this centralized manifest daily across our fleet. So this is using the fleet management tooling that I mentioned before. And again, you can find a blog post around how we do this, where you can read much more in detail. Then to go back to the other part of the question, which was atomic commits. And this is, of course, like one of the things that might seem very, what's the word? Like great thing to get with monorepos. And they are, don't get me wrong. The problem is that once you need to make changes at large scale, you'll find that you can no longer actually use atomic commits, because if you make a change, like let's imagine you make a change, that change affects a few hundred different components, and you want the owners of those components to review that change to make sure that it works, you will now be waiting on the slowest reviewer. And that means that your PR is going to be waiting for a very long time. Google learned this many, many years ago, and there's a great paper from Google on the infrastructure that they used to manage this. So they actually ended up building something that then inspired our fleet management tooling that I talked about before. So they have a system called, I think it's called Rosie. So what it will do is it will take one of these like large changes, and then it will automatically split it up into many, many small changes that are aligned with ownership. So each team ends up getting one change that they need to review, and that can be reviewed and merged independently. And that's just a way to manage scale. So again, atomic commits are amazing when you're able to use them, but you will quickly, at scale, you'll quickly find out that you can't actually do many changes in an atomic way, and you have to split them apart and manage them in kind of a similar way that you have to do in Monorepos. Lots of good questions. Next one, when changing ownership of components, how do you ensure a smooth handover? You mentioned that a team should own the full lifecycle. Yeah, great question again. So we do a lot of ownership handovers. I haven't looked at it for a while, but I think I looked at maybe 2021. We did 500 something ownership handovers in that year. So assuming that has continued, we do like one of these every day or more. And they're not always great. They're not always without friction. We do have some internal handbooks on how to do a good handover in terms of, as the previous owner, what level of quality and documentation and whatnot should you have in place before you try to hand it over, and as a recipient of the thing you're taking on, what should you make sure are in place before you take it on. And then once you have taken it over, you have to be aware that you're going to have to invest some time in like learning how this thing works and whatnot. But it's still super hard for us, and we still end up making a lot of mistakes in that space. So I wouldn't say that we have nailed that part still. And yeah, you're the other part of the question around the team managing the full life cycle. So that is very much true. Like if you own a component, you own the design of that, how it's implemented, you maintain and operate it. You are the one who in the end to decide if you want to decommission it. So like you own the full life cycle of a component, which is great because it creates a very tight feedback loop. So if you are the one that gets woken up in the middle of the night when your crappy code breaks, you have good incentives to write less crappy code. Yep. Next question, how do you ensure that components do not become outdated? So I'm going to answer this from the maintenance perspective, and I already talked a lot about our fleet management stuff. That is mostly the question, and mostly the answer to this question. We try to automate as much as possible of that and make sure that dependencies are automatically kept up to date, that migrations, from some version of Java to another version of Java, or for some framework that we're deprecating, is done automatically and across all components, so that we don't end up with a bunch of stale components. But this is hard. Like, some components, once they are old enough, they will also be hard to manually keep up to date. So we also provide our teams with a lot of dashboards and metrics to make sure that they can identify the components that have ended up being outdated and try to get them back on board. So this is also part of the tech debt work that I talked about initially. Next, how do you manage the overhead of creating new components, including new pipeline, storage, clusters, configs, etc.? So I talked about creating new components before, so I'm not going to cover that again. It's using this wizard thing in Backstage primarily. It also talks about storage clusters, configs, and so on. So it's a good question. So for those, we typically call these resources. I mentioned that we're in Google Cloud, so most of those are Google Cloud resources, although we do use other clouds for some specific things and whatnot. We have infrastructure teams that owns those. If we look at storage, if we look at a database, for example, so if you need to create a big table cluster, which is a type of storage that we use quite a bit, there's a team that owns that and provides tooling and infrastructure for managing big table within Spotify. And typically the way it works, and again, this goes back to the GitOps question as well, we want these to be defined in Git. So for that, we use what we call declarative infra. There's also a blog post on that I would recommend go read. But briefly, our declarative infra is based on Kubernetes manifests and are deployed using a Google product called Kubernetes Config Connector, I think it's called, if they haven't changed the name of it again, which basically takes a resource definition in a YAML file and ensures that the same thing lives in production or exists in production. It's kind of similar to Terraform, which we do use for some specific things, but we find it to be a better abstraction and a tool that is a bit easier to work with than Terraform is at large scale. And again, go read that blog post if you want more information on this. My voice is running out, so I'm going to try to get through the last few questions here. Do you employ consumer-driven contract testing? Already answered this before. We do in a few cases, but not consistently. And maybe we probably should, but we don't. With numerous components, do you conduct chaos testing? Good question. So not in a very structured, not in the same structured way that, for example, Netflix does. This is an area where I would like us to improve, but not something we have been able to invest in any significant way. One thing that we do is that we run in multiple regions within Google Cloud, and we heavily employ those regions in order to ensure good reliability. So that means that if we have issues in a region, that might be a single service that is failing in a region because of some particular thing with that service, or it might be all our services running in that region because of some infrastructure issue. We can transparently move users to another region. And that is something that we exercise regularly. So we will do these regional failovers regularly. I think we did one last week or the week before that. And we will basically take one of our regions, empty that out, move users to other regions, and make sure that that works. And then when we do that, we every now and then discover some dependency some unintentional dependency, and then we go fix that. But we don't do chaos testing at the level that Netflix and some other companies do. I wish we did. Next question, do you maintain a one-to-one correspondence between backend and mobile components? Yes and no. So we do generally prefer an architecture where you have some sort of like backend for frontend type of backend service, a backend service that specifically serves the mobile apps. It might be that it serves multiple components within a mobile app, but that's probably less relevant here. And we typically want the same team to own that backend service and the components in the backend service that uses that, the components in the mobile app that uses that backend service. So that's the pattern that we've seen work the best for us and that we employ for most things. There are exceptions where services may call into our playlist service, for example, where our mobile apps will call into our playlist service, and we don't have that layer in between. But for most cases, we prefer that. Next question from Alexei. Hello, Niklas. Thanks for this session. What kind of process do you have to introduce innovation? Are teams involved in R&D activities? If yes, what are the motivating factors for them? Yeah, this is a great question. So I'm going to try to answer it from two dimensions. So one is innovation in terms of our product, like what we ship to our users, and the other is innovation in terms of our tech stack, and we view those a little bit differently. But generally, the thinking is that, and this goes back to the sort of life cycle that we talked about before, we expect all our teams to innovate on the product that they work on. So our teams typically own what you can think of like a feature in our apps. So we have a search feature in our apps, and there are a team that owns that search, and the expectation is that they will innovate on how to build the best search experience you can do. So in terms of product innovation, most of that happens within our regular product teams, and we do not have a separate R&D team. In fact, we typically call all our engineering teams for, like, that's R&D within Spotify. On the technology experimentation side, it's kind of similar. So we do have some guidelines around how to do technology experimentation because we don't want it to go completely crazy. But we also encourage teams to do that and do it in a sort of controlled way. Most of that innovation, technology stack innovation, happens in our infrastructure teams for natural reasons. Like, they are the teams that are tasked with, operating a Kubernetes cluster in the best way, and they're going to do a lot of innovation to be able to scale those Kubernetes clusters or enable our engineers to work with those Kubernetes clusters in the best way. This is what things like Backstage came out of. Like, Backstage was one of our squads that built that because they wanted to have a better UI for our developers, and then it turned out that was a very useful abstraction. So more and more teams jumped on that and started sticking their stuff into Backstage, and that's how Backstage came about. Next question. With this infrastructure, how do you address latency issues for user-facing or time-sensitive operations? I think I answered this before, so I'm not going to repeat that. It's a really good question, and it's probably worth spending a bit more time on, but I'm not going to do that now because I have one more minute. Actually, here's Katarina, so I'm going to hand it over to her, and my voice is running out.
Yeah, Niklas, well, I should say that you're an absolute leader in terms of number of questions that you have received. Wow. So thank you for the insightful session. We still have several questions, but I think we can spend hours and even days with you, and still people would have more and more questions, because Spotify and what you do in terms of software architecture is really a really great study and very, very interesting. So it's truly fascinating to gain insights into the way things are done at Spotify. By the way, congratulations on your YouTube channel and blog. We thoroughly thoroughly enjoy both and constantly track new videos and articles. So thanks for maintaining it and providing quality content. Actually, this week we're publishing updated website of Global Software Architecture Summit with the call for papers link. So we really hope, Niklas, that you can make it next year, because it's always interesting, and it would be an honor to have you with us again next year. So we hope to count on you.
Thank you.
And thanks again for the session. Let's keep in touch. And yeah, thank you.
Cool. Thanks, everyone, and thanks for all the great questions.
Bye-bye.
Bye-bye.